All right, so let's go through the first 12. This is going to focus a lot on the Roman numerals that we use when metals make more than one charge. So over here, I give you the copper charge. It's +1, and down here is +2. So we know that copper is one of those guys that makes more than one charge. So we have to consider the charge when we crisscross them. So that 1 is going to go down here, and the 2 is going to go there, and we end up with Cu2O. And over here, the 2 and 2 cancel out. So it's a 1-to-1 ratio, so it's just CuO. Now when we write the name, if we were to just write copper oxide, we wouldn't know which is which. We wouldn't know if we have the +1 or the +2 version. So as a result, we have to use Roman numerals. So Roman numerals are going to go up here to indicate that it's a +1 charge, and over here, +2 charge. Now notice, there's 2 coppers in this formula. It's a 2-to-1 ratio here with copper and oxygen, but it's Roman numeral 1 because the 1 doesn't mean this. The 1 indicates that it's a +1 charge. Just like over here, there's only 1 copper in the formula, but the Roman numeral is not a 1 because it's not what it represents. The Roman numeral represents the charge. Roman numeral, charge. So if I look at the names, over here, I see the charge. I don't even need to look at the periodic table as long as I know the symbol for lead. Lead is +4 because the Roman numerals tell me it's +4. Now fluorine, you have to look on the periodic table. Fluorine's in group 7, so it needs 1 more electron, so it's going to get a -1 charge, always, always, always. So +4 and a -1, lead says here, take 4. Fluorine says, but I can't. I can only take 1 electron, but I'll go find some friends. So there's PbF4, 1-to-4 ratio. Now over here, lead's only making a +2. So in this case, lead wants to give away 2 electrons, but fluorine can still only take 1. So crisscross them, and there has to be 2 fluorines to hook up with 1 lead and make them happy. So again, the Roman numeral told us which is which. In both cases, there's only 1 lead. 1 lead, 1 lead. That's not what the Roman numeral represents. Roman numeral represents the charge. Roman numeral, charge. All right, so here we go. We got chromium 2. Oxygen is going to be a -2. So when chromium oxide is formed, chromium's trying to give away 2 electrons, and that's perfect because that's just what oxygen needs. I know oxygen's -2 because I look on the periodic table. CRO, 1-to-1 ratio. Over here, chromium's making a +3 charge. So chromium's saying here, take 3. Oxygen says, but I can still only take 2 electrons, but we can mix and match. A couple chromiums hook up with 3 oxygens, and we have Cr2O3. The 3 goes here, the 2 goes there. That's how you get that ratio. Now, you don't have the Roman numeral, and you don't have the charges. All you have is a formula. So what do you do here? Well, you got to do some uncrisscrossing. So let me make some space here. What we're going to do is take the charge, or take the subscript and make it the charge. So this is going to become a plus. Positives always come first. +2. This 1, we assume it's a 1. It's going to become the charge on the bromine. So it's going to be a -1. Now, before you go and write that manganese, that's manganese, by the way, not magnesium. Manganese. And then it's going to be bromide. Before you write down that manganese is a +2 charge, you always have to check this. Is bromine really a -1? Well, look on your periodic table. You see bromine's in group 7, so it does in fact get 1 more electron. So that's good. Bromine does make a -1, so that means manganese is a +2. So put a 2 in the Roman numerals. The 2, Roman numerals, is the charge. Now over here, if we uncrisscross it, the 3 goes up there, and the 1 goes there. So this manganese is now a +3 charge. Bromine still and forever will always be a -1. So we have manganese with a 3 in Roman numerals, bromide. So that's good for an example where the anion, the nonmetal, is the charge that you get when you uncrisscross. But look what happens here. We got cobalt. This is CO is cobalt. And we see that cobalt hooks up with oxygen in 2 different ratios. So I know it must be one of those guys that makes more than 1 charge. So I can't just say cobalt oxide because that doesn't tell me which is which. I need a Roman numeral there. So here we go. We're going to uncrisscross. Now watch this. We'll switch over to blue. There's an imaginary 1 here, an imaginary 1 there. So if I uncrisscross, I get a +1 and a -1. Now again, like I said, you always have to check your nonmetal, see if it's right. Does oxygen really make a -1 charge? Is that right? Oxygen's in group 6 on the periodic table, so that means it needs 2 more electrons to get to the octet, to get to the 8. So oxygen doesn't make a -1. It makes a -2. So this, when I uncrisscross it, it's not right just the way it is. But a quick fix, we're going to multiply the whole thing by 2. Everything gets multiplied by 2, not just oxygen. So oxygen becomes a -2, and cobalt becomes a +2. Now, another way we could have looked at that, we could have said to ourselves, well, we know oxygen makes a -2, always, and this is a 1-to-1 ratio. Therefore, cobalt must be a +2. Now over here, it's not a 1-to-1 ratio anymore. If we uncrisscross this, cobalt becomes a +2, and oxygen, take that -1 up there, becomes a -1. And we just said that that's not right. Oxygen doesn't make a -1 charge, it makes a 2. So what do? Just like we said, multiply the whole thing by 2. So oxygen's going to become a -2, and cobalt is going to become a +4. 2 times 2. Most ions become 1, 2, or 3, +1, 2, or 3, -1, 2, or 3. Every once in a while, we can see this +4 business pop into play. So that's how we know cobalt's a +4 in this case. All right, so here we go. We got tin with a +4 charge. So we're going to write tin, Roman numeral 4, and then it's hooking up with nitrogen right off the periodic table, so that's nitride, I-D-E. That's a D. All right, so crisscross them, SN3, and then the 4 goes there, N4. And finally, love seeing Roman numerals. I don't have to think. I know that that's the charge. I look at nitride, so I know it's nitrogen right off the periodic table. Nitrogen's in group 5, so it gains 3 more. So it's going to have a -3 charge. Crisscross my charges, 2 and the 3, so it's SN3, N2, and that's tin 2 nitride.